Timers and counters present in the 8051 microcontroller. This might be a very long video, so I might make it in two parts. We'll just see as we go along. So, in your 8051 microcontroller, you have two timers which can be used as counters. And the main uses you'll have is to generate a time delay, which is something you'll need in, well, most of the operations, like for instance, in the case of an LCD or something. Now, to generate a waveform with a specific frequency, this is one place where you can expect a lot of questions. To generate a baud rate signal for serial communication, what is baud rate? Baud rate means the rate at which data communication happens. So think of this as data rate. We look at serial communication later on, so you'll understand why you use baud rate. This is not something that's asked too often, but if suppose the morning set gets the question of timers on how to use it as a timer, afternoon set will most likely get it on how to use it as a waveform generator, but sometimes you might get a question on counters. It really depends. Now each timer is 16 bits wide, but since the 8051 has an 8-bit architecture, they split it up, and you must have seen multiple times that you see TH and TL in all the code. So basically what that means is your 16 bits are split into two segments of 8 bits each, because your microcontroller can only process 8 bits at one time. What do you mean by TH0 and TL0 and TH1 and TL1? Well, like I said earlier, there are two timers, right? So one is timer 0 and the other is timer 1. So TH0 means the higher 8 bits of timer 0. TL0 means the lower 8 bits of timer 0. Remember, I said there's 16 bits, but the microcontroller can only process 8-bit data at any given point in time. So I'm splitting my timer. Similarly, TH1 are the higher 8 bits of timer 1, and TL1 are the lower 8 bits of timer 1. Again, we're splitting it because the microcontroller can only process 8-bit data at any given point in time. Now, where do you use the TH and TL? To hold the value which is needed for generating the time delay. How do you calculate this value? What is the significance of this value? All of this will be covered in this video later on. Now, there are three modes of operation primarily, but wait, you can occasionally have to use the fourth mode, which is called mode 3. So there's like mode 0, 1, and 2. Most of your questions are going to revolve around there. Mode 3 was something which is mode 3 is a 13-bit version which was developed for compatibility with older microprocessors, but you mostly will not have any questions related to that. And to control the timer's operation, there's also a register called the TCON register. So now, how do you calculate the time value which needs to be loaded in the TH and TL registers? So basically, how exactly the timer works is the microprocessor has these timers. Now what it's going to do is it's just going to start, you're going to fill up, it's like imagine a petrol tank, all right? I fill the petrol tank of the car up to some level. I find out how much this level is by doing some calculation. And once it's filled to this level, my petrol tank is designed in such a way that once the tank gets filled, a cap will open at the bottom, draining everything instantly. So now, when I want the timer to run for some operation, I find out how much I need to fill such that the time for which my timer has to run will be equivalent to the empty space. Let me go over it once again. I will fill, suppose I want my timer to run for some Y duration. I will fill the petrol tank with an amount X such that by the time it takes me to fill up the rest of the petrol tank, that time is equal to Y. So that's how the entire timer concept here works. So now this Y value is something which we want, and this X value is what we're going to calculate and store it in the TH and TL values. How do we calculate X? So you divide the desired time delay. Suppose you want like 50 milliseconds. What is 50 milliseconds? Y. What is Y? The time it takes for me to fill up the petrol tank. Suppose I want a 50 millisecond time delay, then what I'm going to do is divide 50 by 1.085 microseconds, get some value. That value let's assume that value to be, well, value. Let's just write value. Then what I'll do is I'll do 65536 minus value, which will give me another value. Now this value, you will be converting this using your calculator into hex to get some other value, which is going to be about 4 alphabets. Then you split this into 2 bits. This is going to be loaded into your th, and this will be loaded into your tl. That's how you find the value of x. Now, why does 1.085 come? Here comes the interesting concept of machine cycles. So imagine that for you to function, you have to, well, let's imagine that for you to function, your heart has to beat one time for you to perform any task. This heartbeat of yours, each time it beats, it's one machine cycle. Similarly, in the microcontroller, for any work to happen, one machine cycle implies one line of code executed. You can say it in that sense. Or, well, this is not entirely accurate. I'm just saying this so that you have a picture in your head. So suppose you as a human have to pick up a ball and you're standing there. Your heart beats the first time, you'll walk to the ball. Your heart beats the second time, you reach out to the ball. Your heart beats the third time, you pick the ball up. So it took you 3 machine cycles to pick up that ball. Similarly, the microcontroller needs to runs on the basis of a machine cycle. Now, how do you define one machine cycle? Well, if you remember in my 86 videos, I mentioned that every single microcontroller in the world to this day has something known as a crystal, usually a quartz crystal or a Swiss quartz crystal. What is that? It's basically something. It's like a stone. It's a stone, which when you put it in some when you apply some current or voltage to it, it vibrates to and fro, generating a clock signal. Now, this is the signal which obviously has some frequency f. In the case of 8051, it's usually 11.0592 megahertz. Now, what this value represents is that in 1 second, the crystal of an 8051 vibrates these many number of times. How do I find out the machine cycle's duration? So what you'll do is, you'll do 1, to find out the time period, you do 1 by f is equal to t, which in this case will be 1 by 11.0592 into 10 to the power 6, which should give you the value of, let me just calculate that real quick. Approximately 0.090422 microseconds. Now, one crystal cycle, that is one time the crystal moves, takes this much time. So now, in the 8051, it is defined that this time multiplied by 12, like whatever time you get over here, suppose your crystal is of a different frequency, you'll obviously get a different time. When you multiply that by 12, that will give you one machine cycle. So this is very important, because in most cases, if they do not mention the crystal frequency, you can assume it to be 1.0592. You do 1 by this value and multiply by 12, you will get 1.085 microseconds. However, in some questions, they might say that it's a 22 megahertz crystal or a 33 megahertz crystal. In that case, this is an important calculation. Now, let's proceed with whatever we were doing. So yeah, that's how you load up the values of TL and TH to make your timer function. So now let's look at this question. Suppose you want a 500 microsecond time delay. Similar to what I said earlier, 500 divided by 1.085 microseconds, you get how many pulses you want. This value, you can subtract it from 65536. Why 65536? Because that is the value of FFFF. Now let's look at the petrol tank example once again. The reason I explained this petrol tank example was how your 8051 works is your TH and TL registers. Suppose you're using timer 0. It is divided into TH0 and TL0. So let's take this petrol tank, split it in half. TH, TL. Now what your petrol tank is going to work like is you want a delay of y seconds, which is the emptiness. So how the 8051 microcontroller does is it will, whatever value of x you get, it will start incrementing from that value. So if this value is x, it will start incrementing. That means it is going to start climbing up one by one all the way until it reaches FFFF, which is 65536. Well, it's 65535, but then if you include this, but then since you're counting the number of bits, it'll be 65536. That is why you use 65536. So you subtract 461 from 6.65536 to get this. When you convert it to hexadecimal, you get 5 FE33. So this thing is split into 2. So 33 goes into your TL and FE goes into your TH. Do not get confused by the 0 multiplied by that. That's just a way of writing it. You're actually loading the values of FE and whatever the other thing was. Now, your TMOD register, like literally any other register, like R5 or anything, you access your TMOD register. TMOD is an 8-bit register, and there should be a diagram over here. It's split into 2 halves, yeah. So the TMOD register is split into 2 halves. The lower 4 bits define the functioning of timer 0, and the upper 4 bits define the functioning of timer 1. So gate bit is something which you always usually set it as 0. Now, how do you define the tmod value? In your code, you're going to write move tmod comma hash 01h. When you write a hexadecimal value like this, you might think, oh, this is 8 bits, I'm only writing 2. No, but the thing is, you're writing in hexadecimal. So this thing is actually, when you convert it into binary, is 0000, 4 bits here, and 0001, 4 bits here. That's how it works in hexadecimal. So 0000, what does that mean? Gate 0, C/T0, 00. Over here, I defined as 0, which means I will not be using timer 1. 0001, gate is 0001, which means since I have it set this way, I'm going to be using timer 0 in mode 1, which is the 16-bit operating mode. Now, in the 8051 timers, you can, one unique feature about it is that you can start and stop it either by software control, which is the thing which you will be doing when you write all your codes and define it, or they can be a hardware control. In using the software to start and stop the timer when the gate is 0, let's look at this. The start-stop timer are controlled by the way of software by the TR bits. So you will look at what exactly TR is when we have a look at the codes. Think of TR as basically the guy who flags off the race, or the person who defines if an event is going to be happening. You will have the TR bits for the lower and the upper timers separately. When we look at the codes, you'll understand the functioning of that better. TCON register. This is something which you'll actually use a lot when it comes to interrupts. But basically, this can also come as a theory question. So just have a look at this. It's essentially just the functioning, not really much to explain here, very self-explanatory. If you have any doubts, you can obviously reach out to me. I'll put the email address in the comments. Sorry, in the description. So yeah, let's just directly look at some programs. Right, so let's have a look at this program. Now, what you do here is, first of all, let's go to understand and remember the programs. One good way to do it is follow a systematic approach in your head. So now, suppose I tell you that I want you to generate a square wave, or I want you to make some time delay of x microseconds. Now, before you can, how do you make a time delay? You have to use your timer. How do I use my timer? First things first, I have to define I need to choose the timer I'm using and in what mode I'm using, because I have two options, right? Timer 0 or timer 1. So what will be my first step? Defining the timer I want to use and the mode I want to use it in. That's why your first step is always going to be move t mod whatever value you want. Your second step is going to be, once you've chosen the timer, now you have the timer with you, which is a 16-bit block, right? Now you have to fill in the 16-bit block with values. How do you fill it? Well, you split the 16-bit block into two parts, th0 and tl0, or th1 or TL1, depending on what you're using. Once you split that, you have to load the values into it. How do you load the values? You have to do the calculation first. So in your paper, you're going to first do the calculation and then the code. And in your code, first things first, you define the timer and the mode. Then you load up the calculated values into TL and TH respectively. Now that you've loaded up the values, you are ready to start counting upwards. So that's when you do set bit. It's like, imagine you have a race and you have cars lined up at the track ready to start. You need somebody to flag off the race. That's a checkered flag, by the way. Once everybody is ready at the starting point, that is this step, this checkered flag waves and you start the race, that is this step. Till when do you continue the race? Till basically you get a winner. Now, how are we going to define a winner in the case of a timer? Here is where TF comes into play, which is the timer flag. So basically, do you remember in the petrol tank example, I said you're going to start filling up the tank, right? Now, how do you know when the tank is full? There will be a notification which is sent off. That notification is going to be your timer flag. So basically, your petrol is going to continuously pour into the petrol tank, and once it's filled to the brim, your timer flag goes like, hey, my petrol tank is completely filled. That's how you know that the petrol is all the way to the top. So now I just need to look at my notification, which is my timer flag. How do you polling, or how do you continuously look at that? Well, you use this instruction, jump if no bit. JNB stands for jump if no bit. I am going to continuously look at this notification light of mine till it starts glowing. Unless it's glowing, I am going to jump to an address called back. So if no bit, that means if the light is dim, I will go to this address. The moment the light starts glowing, I will go to the next line. That's what the JNB instruction does. The moment my light starts glowing, that means I have finished filling my petrol tank and then I've emptied it, which is the time delay which I want, right? That is why. Once that is done, what do I want to do? I want to keep generating this time delay. I want this to be infinitely long. So what will I do? I will clear TR1. That means the person who was waving the checkered flag, I will get him to stop waving the checkered flag. Then I will clear TF1. I will switch this bulb off. I'll replace it with a new bulb so that I know that once the petrol tank gets filled again, I need a new bulb, right? Then I will do now the CPL P2.3. Basically, in the question, they have told you that they want a square wave, and the square wave needs to be generated at P2.3. What does CPL do? It's complement. So whatever value P2.3 is, suppose P2.3 was initially 1, that value is going to be held till when? Till the timer is doing its work. So that value is going to be held. Now then, once the timer has finished its work, you do these two things, then you complement it. So you make it 0. then S jump again, which means you again load up the timer with the same value. Again, you start counting. All of these functions are going to take some time. That is how you generate the square wave. That is how you get the wave. I've explained this in my previous video as well, when about IO ports. So yeah, that's a basic code on how timers work. We will look at the other modes of the timers in the other video. For now, I think it's this much. If you guys have any questions, you can send a mail to the ID down in the description.